Good morning, students. So today we'll deal with this topic, inverse trigonometric functions and their solutions. This is some of the miscellaneous exercise questions I'll be taking from NCERT. So let me take up one question first. Let us see this one. Here, suppose I have to simplify what is cos inverse. This is the first question, cos inverse cos 13 pi by 6. I have to simplify this one. So this is my first question. I have to simplify cos inverse cos of 13 pi divided by 6. So you can see I cannot here cancel cos inverse and cos because I cannot write the answer to be 13 pi by 6, since our cos inverse x can range only between 0 to pi. So this is the branch. My answer must be confined into this. So how to solve that? Let us see this one. So first I will convert this one as I'll confine my values within 2 pi. So cos inverse cos of this is 13 pi by 6. So I can write this is 2 pi plus pi by 6. Now let us recall the quadrant notation. This is 0 and this is also 2 pi. So 2 pi plus something, it will lie in quadrant first. So in the first quadrant, whatever the value of cos, that is positive. So cos, and remember children, in trigonometry the value 2 pi is same as 0 because they are the same locations. So I'll have here cos in place of 2 pi plus pi by 6, I can write as pi by 6 because treating 2 pi as the initial point. Cos inverse cos, they are getting cancelled and I am writing the answer as pi by 6. Okay, so now I think this is clear to you. Now let me tell this one. I have to prove tan inverse, question number 7. Please see, tan inverse 63 by 16. Let us see. I have to prove tan inverse 63 divided by 16 must be equal to sin inverse 5 by 13 plus cos inverse 3 by 5. So let us deal with this type of questions. So before starting, I have told you always the RHS is more complicated. So I will start from RHS. RHS is nothing but sin inverse 5 by 13 plus cos inverse 3 by 5. Now my target is to convert them into a single inverse trigonometric function. So for sin inverse 5 by 13, you draw this triangle. So here do some rough work here. This is sin inverse, it is p by h, so p is 5 and h is 13, so clearly this one will be 12. So that will be equal to cos or tan inverse 5 by 12. Similarly for cos inverse 3 by 5, you have this one, have this triangle with you. This one is 3 and this one is 5. So obviously, sorry, this is not 3 because it is b by h, so this is 3 and this is 5, so this is 4. So it is also tan inverse 4 divided by 3. So I will be writing both the cases here. Sin inverse 5 by 13, this is nothing but tan inverse 5 by 12 and this is nothing but tan inverse 4 by 3. So this is tan inverse 5 by 12 plus 4 by 3 divided by 1 minus 5 by 12 multiplied by 4 by 3 using the formula for tan inverse x plus tan inverse y. So this is nothing, 5 tan inverse, they will be multiplied, this is 15 plus 48 divided by this one is 36. I am doing it directly, so this is nothing, tan inverse 63 divided by 16. So this is how we prove this result. Now let us move to the next question. In the next question, I have a question for you. These are very important questions. Let me deal with question number 9. So in question number 9, we have to prove tan inverse root x equals to half cos inverse 1 minus x divided by 1 plus x. So I have to prove this result, and here let us start from LHS. So LHS, suppose I take let x equals to tan square x or tan square theta. So our LHS will be tan inverse root under tan square theta, that is equal to tan inverse, again this is tan theta. So tan inverse and tan are together, so the answer is theta only. In RHS, I'll have half of cos inverse, in place of x you put tan square theta, divided by this one again becomes 1 plus tan square theta. So this is equal to half cos inverse 1 minus tan square theta by 1 plus tan square theta. It is the formula for cos 2 theta. So cos 2 theta has another formula, that is 1 minus tan square theta divided by 1 plus tan square theta. So it is equal to half. This is cos inverse and cos, they are together, so the answer will be 2 theta, and half and 2 are getting cancelled, and at last I will get theta. Therefore I will have LHS is equal to RHS, and the things are proved. Now let me take another question. These are very important one. So look at question number suppose 11. See, in question number 11 I have to see tan inverse under root 1 plus x minus under root 1 minus x divided by under root 1 plus x plus under root 1 minus x. It is equal to pi by 4 minus half of, this is not properly visible, let me see this one, half of cos inverse x. So now this is minus half of cos inverse x. Now let me prove this one. I'll start from LHS. This is tan inverse under root 1 plus x minus under root 1 minus x divided by under root 1 plus x plus under root 1 minus x. So I will do it by suitable substitution. Now for substitution I have to choose a value of x for which 1 plus x will give me some result, as well as 1 minus x should also give me some result. So I know a formula, 1 minus cos theta, it is equal to 2 sin square theta by 2. Also I know 1 plus cos theta, it is equal to 2 cos square theta by 2. So if I take here x equals to cos theta, then 1 minus cos theta will give me one result, 1 plus cos theta also will give me some result. So in the beginning I will let x equals to cos theta. This is very important point for this question. So tan inverse, this is under root of 1 plus, in place of x I will write cos theta plus under root of 1 minus cos theta whole divided by under root 1 plus x, 1 plus cos theta, in fact 1 plus cos theta, this is minus and this is plus, under root of 1 minus cos theta. So let me simplify this one. This is tan inverse 1 plus cos theta, this is under root of 2 cos square theta by 2 minus under root of 2 sin square theta by 2 whole divided by, this is under root 2 cos square theta by 2 plus under root 2 sin square theta by 2. Now tan inverse, this is root 2, I will be taking common because root 2 and root 2 will be both here. So if I take root 2 common, what will remain is cos theta by 2 minus sin theta by 2 whole divided by, this one will become root 2 cos theta by 2 plus sin of theta by 2. Now here root 2 will get cancelled and will solve it again. So I'll have here, this will be equal to tan inverse, this is cos theta by 2 minus sin theta by 2 whole divided by cos theta by 2 plus sin of theta by 2. So whenever we come across this form, but I need a formula for tan here, So what you do, divide both numerator and denominator by cos theta by 2. This is a fixed procedure for tan, dealing with tan, sin and cos. This is divide both numerator and denominator by cos theta by 2. This is cos theta by 2 divided by cos theta by 2 plus again sin theta by 2 divided by cos of theta by 2. So what did I do? I divide cos theta by 2 both in numerator and denominator. So here you get tan inverse. This is 1 minus tan theta by 2. Again this is 1 plus tan theta by 2. Now I have to apply a bit of trick here. So tan inverse, this is tan pi by 4 minus tan theta divided by 1 plus tan pi by 4 by 2, it is into tan theta by 2. Why did I put tan pi by 4? Because tan pi by 4 is 1. Wherever I whisper, I can use that one. Now look at this. This is in the form of tan A minus tan B divided by 1 plus tan A multiplied by tan B. So this is the formula for tan first minus second. And here again I am getting tan inverse and tan A together. So the final answer is pi by 4 minus theta by 2. That is equal to pi by 4 minus half. In place of theta, look at this. I have taken in the beginning cos theta equals to x. So in place of theta, I can write it is cos inverse x. So this is, I will conclude my answer by cos inverse x. So this is the completion of my proof. Look at this. The question was this: tan inverse this equals to pi by 4 minus half of cos inverse x. So now the last question for today, I will solve it, and you try to understand that. This is important. Once or twice it has been asked also in the CBSE exams. So this is question number 12. Please see this question. 9 pi minus 8. I have to prove this result by minus 9 by 4 sin inverse 1 by 3 equals 9 by 4 sin inverse 2 root 2 divided by 3. So this is our question number 12. I have to prove 9 pi minus 8 minus 9 by 4 sin inverse 1 by 3, it is equal to 9 by 4 sin inverse 2 root 2 divided by 3. So you start from LHS first. LHS is 9 pi by 8 minus 9 by 4 sin inverse 1 by 3. So from these two I can take 9 by 4 outside. What is left with me is pi by 2. 9 by 4 I have taken outside minus sin inverse 1 by 3. So this is equal to 9 by 4 times pi by 2 minus sin inverse theta or anything can be written as cos inverse 1 by 3. Since I have a result cos inverse x plus sin inverse x, together they will always be pi by 2. Now my job is not over yet, because I have to find here 9 by 4 sin inverse 2 root 2 by 3. That means I have to now convert cos inverse into sin inverse. So let us draw a triangle for you. First, cos inverse is b by h, so I will take it as 1 and I will take it as 3. So in this case b equals to 1 and h equals to 3. So therefore p will be square root of 3 square minus 1 square, which is under root 8, which is 2 root 2. So the same thing, that means this side will become 2 root 2. So this is equal to 9 by 4 multiplied by sin inverse. This is p by h. In place of p, I should write here 2 root 2 sin inverse 2 root 2 divided by h, which is 3. This is equal to RHS. Very important question, and we'll be talking, this is about NCERT important questions. You solve all your doubts and you can send your problems to this DAV Gumla exams @gmail.com. So your replies will be sent to you through email, and you solve most of the questions. If any question is there, you can send it here. and tomorrow we'll deal with CBSE questions from this chapter. Okay, thank you very much. That's all for today.